Welcome back.
All right, welcome back. Yeah, we had to take a break from you guys, but we are going to do problem number 3, and we're going to graph this wonderful ellipse. And the reason that you know it is an ellipse or a circle, anybody?
Negative, positive.
Yeah, no negatives. This is x squared, and this is positive.
But there's a
Positive x squared and positive 9y squared. These negatives on the
Are not relevant.
they're
So what is relevant? The first two? Yeah, x squared and y
The
squared.
ones that have squared. Alright.
I just had to sneeze and it was not working.
You're getting double.
Okay.
You're gonna pass out. So it's x squared and the 9y squared that matters. So if that was x squared minus 9y squared,
It would be a hyperbola. Yep. So this x squared right here, I can complete the square on that. So I'm going to leave a space. I'm going to do 9y squared minus 54y. Now this gets a little harder again, so hang in there. So I'm going to, and I'm going to subtract this constant and get it over here. Get it out of the way.
For sure.
All right, so when you complete the square, you have to have a 1 in front of the x squared term or the y squared term,
So
which we have right here.
it'd be
So,
plus 4.
yeah, you're going to do half of 4, which is 2. 2 squared is 4. So we're going to add 4. So add 4 over here.
Negative 27 squared.
Now the complicated part is going to be on the y part. So this right here is just like we did it with the circles. This will be, what is this going to factor into?
2.
X plus 2.
X plus 2 squared. Okay, now this has a 9 in front of it. We don't want the 9 in front. So what I'm going to do is I'm going to, from those two terms, I'm going to factor out a 9. Don't do it, Hunter. So if I pull a 9 out
9.
here, I'm going to change that to an 8. All right, then I'm going to have, what would be left inside the parentheses?
Negative.
Well, you'd have a y squared minus, no, because we're factoring out a 9. So, what's 54 divided by 9? 6, yeah. So this would be 6y. Hunter, you better be writing this down. This is some good stuff right here. Okay, so now what we're going to do is we're going to...
Wait.
I'm telling you.
Why didn't you take out half of... You're right, buddy.
I had to factor out a 9, and don't say it.
Why didn't you take out half of 54 squared?
Because I have to factor out a 9 first.
No what?
I have to factor out 9 first.
You just shriek.
Right. If I factor out a 9, then if you distributed the 9 back through, it would be 9y squared minus 54y. And then now I'm going to complete the square, and I'm going to go plus half of negative 6 squared. So I'm going to 9. Oh my gosh. All right, so then this equals, on this side, if I add the 4, it's negative 72.
From half.
I added 4 there, so I have to add 4 here. All right, but we are not done because we just added a 9 over here. And that 9 is being multiplied by that 9. So what is that? What's 9 times 9?
81.
So we just added 81 instead of 9.
So then you add 81 to the other
To
side.
add 81 over here. So plus 81 on that side. Okay? So this is going to stay as it is. This is going to factor, what does this factor into?
Y minus 3.
Yep. Very good. Equals, that's, oh, we're not done because it's not in standard form because I have a 9 here and I need it to be a 1.
Divide by 9.
So we're going to, yes.
Divide that by 9. Divide that by 9.
Everything.
Divide that by 9.
Oh, there's a whole lot of 9s.
All right, so when we do that, we divide by 9, we divide by 9, we divide by 9, yes. And we get, this is going to simplify to 1 over 1, no more 9s. This is also going to simplify to 1. So we end up with
x plus 2 squared.
X plus 2 squared.
Y minus 3 squared.
Yep.
Equals 1.
Oh, and you can put over 1 just to keep track of that. That's going to be your b squared equals 1. So what is the center of this ellipse?
Negative 2, 3.
Negative 2, 3. Very good. And a squared is 9, and b squared is 1. So a is 3, and a is going to be 3, and b is 1. So if you're going to graph this, you're going to put the center at negative 2, 3, and then from that center, you're going to move 3 units left and right, and then 1 unit up and down.
So
Would you like me to graph it?
Wait, 3 units?
A squared equals 9 would actually be 3. Okay.
Oh, so you're saying a squared is 3 because you take half of 9. Oh, wait.
Okay, so my center, let's do this. Center is at, what was the center at? Negative 2, 3.
Negative 2, 3.
And then a squared was 9, which means a is 3. So you gotta take always the square root. And b squared was 1, so b is 1.
Oh.
So when you graph it, you're gonna put your center on there.
Negative 2, 3.
Yep. Negative 2, 3 is right here. And then you're gonna go, the 9 was underneath the x squared, so we're gonna move, or that a squared is 9 that was under x, so we're gonna move in the x direction, square root of that, which is 3. And then this way 3, which puts us at 1. And then how far am I gonna move up or down? 1 unit up, 1 unit down. And so you're gonna have this really skinny ellipse like that, whichever way I think of it. So this has eccentricity that is close to 0, and I don't think that in this, we don't talk about eccentricity. We only talk about eccentricity. All right, so back this way, we have hyperbola with a center of hk. So if the center changes to hk on a hyperbola, it's very similar. It's just going to be x minus h squared over a squared, and then it's a hyperbola. You can tell it's a hyperbola because of the minus sign, and y minus k squared over b squared. It'll have center h comma k, so again it's the opposite. The vertices are going to be at, you're going to need to follow this formula. You're going to know your hk, and then you just go h plus or minus a, take the square root of that, and then comma k. And if it's this way, where the negative is with the x squared, then the center is still going to be hk. So you guys have to make sure you're looking at this or paying attention right now. The center is not going to be this. It's going to be still x, y. So it's still going to be h, the number that's associated with the x term, and then the number associated with the y. And
do the vertices do that as well?
The vertices are going to be h. So the vertices are going to go up and down instead of, remember if the y part is positive, it's going to do that. If the x is positive, it's like that. So the vertices are going to be these points, and I'll show you in a minute how that works.
K plus B?
K plus or minus B. Yep. That's in the middle. So you figure out what hk is, and then plug it into this formula. A and B are the square roots of the numbers there. All right, one more problem for hyperbola. And then we're moving on. Maybe I'll have you do a couple problems if you want to. And then we have second degree inequalities and non-linear systems.
It was a lot of space.
Yes, I did. All right. We have a hyperbola. How do you know it's a hyperbola?
Minus x squared.
No.
We're writing all this, right?
Yeah.
Oh, yeah.
Well,
Okay, so group your x terms, which is only 1. There's nothing to complete the square with. There's no other x terms, so you don't need to do that. So that means that the x coordinate of the vertex is going to be 0, because there's no x minus anything. So I'm just going to write right here, what do you think I'm going to factor out of, I don't need to actually factor anything out, but I actually do need to factor out a negative 1. Yeah. So this would become y squared plus, nope. If I factor out a negative, what does this become? Yeah. So it'll be y squared minus 4y. And I am going to complete the square on that, so I'm going to leave some space. And what are you going to do with that minus 20?
Add it to.
Add it to the other side. That is the absolute correct answer. Complete the square. What are you gonna add? Right, half of negative 4, negative 2 squared is 4. But what do I do for this side? No. Look at it a little more carefully.
Negative.
Yeah, you're gonna add a negative 4 because that's
Distributing that negative.
you. Instead of adding 4, we actually just subtracted it because it gets multiplied by that negative up front.
Okay.
All right, so you gotta watch that. You gotta be really careful. Well, I have a negative. If I distribute this back through, this would be 4x squared minus y squared minus a negative plus 4y, and minus the positive is minus 4. So we really just added a negative 4. We didn't. I mean, we added 4 inside the parentheses, but it's getting multiplied by that negative outside the parentheses. All right, so now we can complete the square on the on the y. So we have, what do we factor into? Y minus 2 squared equals 16. And I want this side to equal 1. Yeah, divide everything by 16. Alright, so we have, I'm going to simplify. So this becomes x squared over 4 minus y minus 2 squared over 16. There's nothing to simplify there. Equals 1. The hyperbola, the center of the hyperbola is what? It's going to open left and right because of the x being squared instead of the y. I mean, the x being positive. You could put x minus 0 squared if you wanted to, and then h would be 0.
X is 0. I thought x is.
We already know 12 yet, aren't we? This is 12-3.
No, this is the last problem from 12. So, the center
A is 2 and your B is 4.
Yep. A is 2, B is
I don't get it.
what don't you get? The A, the B? The center?
Center.
I could rewrite this if I wanted to as x minus 0 squared. So, oops, that's a minus. You remember way back when not way back, I guess it was not long ago, we were looking at hyperbolas centered at 0, 0. A hyperbola centered at 0, 0 would just be x squared and y squared, no minus anything. So if it's just x squared and no minus an h value, then it's 0. Alright, so. Alright, so then you guys are going to draw dotted lines through those corners of your rectangle, and your hyperbola follows those dotted lines like so. So about like that. So the hyperbola is actually just these blue lines. Maybe I should highlight.
Oh, I remember doing this.
Huzzah!
Nice. That is the hyperbola right there, those two lines. And so you use the A to find the vertex, and you use the B to find the corners. And then you draw dotted lines, and those are lines that just guide you to tell you how wide the hyperbola is going to be. So if it was this way, it would just, you would have the if it was a y instead of x, you would just draw it here, and it would be a center hyperbola and opening this way. Okay. So,
Drop in their face.